Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 14 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3337. Total characters in a string after transformations 2. Okay, so let's read the problem statement first. So you are given a string S consisting of lowercase English letters, an integer t representing the number of transformations to perform, and an array nums of size 26. Okay, so in one transformation, every character in S is replaced according to the following rules. Alright, so replace S of I with the next nums of S of I minus A consecutive characters in the alphabet. Okay, so let's understand with the example here. So let's suppose your S of I is equal to A and nums of 0 value is equal to 3. Okay, so we have two arrays given to us, right? One is this S, okay, input string given to us, t some variable, okay, so number of transformations given to us, and this nums is nothing but a list of integers. Okay, list of integers, right? So here see, if S of I value is A, okay, if the character at I index is A, and nums of 0, if you check, okay, if it is equal to 3, that simply means that we have to update this A with B, C and D. Okay, the character A transforms into the next three consecutive characters ahead of it, which results in B, C, D. Okay, so A is going to be transformed to B, C, D. Okay, so A frequency is going to become 0 and B's frequency is going to become 1, C frequency is going to become 1, and D frequency is going to become 1. Okay, same way the transformation wraps around the alphabet if it exceeds Z. Okay, so for example, if S of I value is equal to Y and nums of 24. Okay, so here you know now that A we represent with 0 index, okay, 1 we represent with B, right, and C simply means 2 at 2 index. Okay, D means 3 index. Okay, same way X is 23, Y is 24 and Z is 25. Okay, so total 26 alphabets, right? So we are starting from 0 and ending at 25. Okay, so here if S of I is equal to Y, so we have to check nums of 24 then. Okay, so nums of 24 is 3. So now next characters after Y, so we are going to take Z and then we have to take A and B. Okay, so it transforms into the next three consecutive characters ahead of it, which results in ZAB. Okay, and in the end we have to return the length of the resulting string after exactly t transformations. Okay, and since the answer may be very large, so we have to return it in a modulo 10 to the power 9 plus 7. Okay, and these are the constants, right? So s dot length 10 to the power 5. Okay, and t value is also ranging from 1 to 10 to the power 9. Okay, so this is the case, right? So we can't apply normal approach here, right? Otherwise we will get time limit exceed error, right? So here s consists of only English English lowercase letters, and nums dot length value is 26 and nums of I value from 1 to 25. Okay, that's clear, right? So now here first see this example only. So here if you see, this is your input string a b c y y and t is equal to 2. Okay, so two transformations you have to do. Okay, so a is going to a value is 1 here. Okay, at 0 we have to check, b at 1 we have to check, c at 2 we have to check. Okay, so here if you see, so a becomes b, right? Same way b is going to become c, c is going to become d, and y is going to become here 1 only, right? So y is going to become z, and this y is also going to become z. Okay, so now your string after the first transformation is going to be this b c d z and z. Okay, now you have to take this string, again you have to do the transformation. Okay, so we have to do total two transformations. Okay, so if you take this string, so now your b is going to become c. Okay, so for b value is 1, so only one, next one character, c next one character, d only next one character. Okay, and here z, so z here it is saying that next two characters will be modified. Okay, z is going to transform into two new characters. Okay, z means a and b. Okay, so here see, b is going to become c, then this c is going to become d, then this d is going to become e, and this z is going to become ab, and then this z is also going to become ab. Okay, so here if you see your new string, C D E A B A B. Okay, C D E A B A B. Okay, and we have to do total 2 transformations only. So after 2 transformations, if you see, the total length of string is 7. Okay, so this is a normal approach, right? First, for t is equal to 1, we have calculated all this. Okay, B C D Z Z, and we form this string. Now take this string and do the next transformation. Okay, so same way here, see, t is equal to 1, t is equal to 2. Okay, if t value is 10 to the power 9, then it's the issue, na. T is equal to 10 to the power 9, then this string length is also 10 to the power 5. Okay, it may reach, so 10 to the power 9 into 10 to the power 5, so you will get time limit exceed error. Okay, so we have to think about some better approach. Okay, so here now see this. So let's suppose your s value is equal to a, and here I am asking you guys to do total 5 transformations. Okay, so here this is nums value, nums list. Okay, so for this is 0, right? 0 means a. So okay, and here this is 1 index, 2 index, 3 index, 4 index, 5 index, 6 index, 7 index. Okay, and here I can write b, c, d, e, f, g and h. Okay, same way it is until here. Okay, so this is nothing but 25, and you can say z, right? So first time your a is going to be transformed into b and c. Okay, so 2 characters we have to transform now, next 2. Okay, so here at a 2 now, so b and c, so a is going to transform into b, c. Okay, so here see, the length of this string after one transformation is 2. Now your b is going to be transformed to cd in the next step, and your this c is going to be transformed into de, right? De. So total string that you are going to get now is cd de. Okay, so this is having length 4. Okay, this is a new, right? cdde having 4 length. Okay, now here pick this string. Okay, so c is going to be transformed into d and e, then next d is going to be transformed into e and f, then next d is going to be transformed into e and f, and then next e is going to be transformed into f and g. Okay, so f and g. So here if you see this, so this is having length de, ef, ef, and here fg. Okay, so here this length is nothing but 8. Okay, so here this length is nothing but 8. So here I can write this as 2 power 1. I can write this 4 length as 2 power 2. Okay, and here I can write this as 2 power 3. All right, so now if you solve this further, okay, so here you know that for all the characters like d's, 4d, all are 2 now, so only 2 we are doing right here. So same way now here start from here. Okay, so here if you start from here, so d is going to be, you are going to write d like this, d, e, f. Okay, then next e you are going to write it as f, g. Okay, then next e you are going to write it as f, g. Okay, then next f is you are going to write as a b c d f g h. Okay, then here this e again, e you are going to write f, g, then next f you are going to write as g, h. Okay, then next f you are going to write it as g, h, and next g you are going to write it as b c d f g h i. Okay, h i. So here now if you see this length, 2 4 6 7 8 9 10 11 12 13 14 15 16. Okay, so 16, so here 2 power 4. Okay, so this is for 4 transformation. Same way for, if I do it one more time now, so I will get 32, that is nothing but 2 power 5. Okay, so here you see we can directly calculate this now. So a, okay, for a this is 2. Okay, this is 2 given to us, right? Here for this a nums value is 2. Okay, so 2, here number of transformations we have to do. Okay, so number of transformations we are doing here 5. Okay, and what is the frequency of this a, frequency of this a, frequency of this a, transformations of this a. Okay, so 2 is for a only, so this is what we need to do, right? So frequency of a is just 1, so 1 into 2 power transformations. Okay, 2 power 5, so 32 we are going to get. Okay, so this is for this. Okay, so here you see output is 32 for this. Okay, so how I'm going to solve this actually? So now see this diagram. Okay, so initial frequency, so here a b c d e f. Okay, so all are 0 only except this a. Okay, since only a is given to us, right? So I have calculated the frequency of this string, right? So now we have to make one base matrix. Okay, so here in base matrix, so you know that for a, okay, so first see this here what is this saying? So this is saying for A we have to change it to BC. Okay, this two values saying us that for B we need to convert it to CD. Okay, so here is also 2. So next two characters we are modifying for all the these characters. Okay, so here that's what I'm doing here. Okay, so here A, so for A can become B and C, so that is why here I'm writing 1 1 and all other are 0 only, right? Same way B can form C and D, so here C, B can form C and D. So here see this and this I'm representing. Okay, so A, B, C, D. Okay, this is D, this is E. Okay, so here 0, 1, 2, 3. Okay, rows. Okay, so until 25 we have rows. Okay, and here also same A, B, C, D, E until 25. Okay, 0, 25. So here A to B I can convert. Okay, so A. Okay, if I have A, so A is transforming into B and C. Okay, because here value is 2. Same way B is transforming into C and D. So here I'm writing 1. Okay, C is transforming into D and E. D is transforming into E and F. Okay, E is transforming into F, G. Okay, E is transforming into F and G. Okay, so here A is D, E, F, G, H. Okay, so this is what I'm writing. Okay, so this is nothing but a base matrix first. Base matrix. So A is converted to B and C. So that is why 1 1 here. B is converted to C and D. That is why 1 1 here. Okay, same way here Y is modifying into Y is changing into 2 now. So next to Z and A. So here see for this Y, this is Z and this is A. Same way Z is modifying into A and B. So here that is why A and B. Okay, so this is what we need to do. So this is going to be my base matrix. Okay, so we are going to write the one code for this base matrix. Okay, so this is my base matrix. Okay, this is one thing, right? This is very simple, right? Now after that you are going to write all this. So first your A is going to convert to BC. Okay, A is going to convert to BC. Okay, so you are going to get something like this, right? And then your B is going to convert to CD. Okay, B is going to convert to CD. Okay, so here C and D. Okay, all this. So you are going to fill this and you will get one final matrix. Okay, so you will get the resulting frequencies of like this. Okay, so this simply means how you can form A. Okay, you are going to start from all the characters like A, B, C, D, E until Z. Okay, from all this how you can reach A, in how many ways you can reach A. So here you are going to get some 0 only. Okay, 0 only, 0 only, 0 only, 0 only, 0 only. Okay, so here you will get 1, 5, 10, 10, 5, 1, and you have to just do the addition of this. Okay, so I will also show you how we are going to get this resulting frequency. Okay, so this is one base example. Okay, I will show you with this example, this main big example. Okay, example number 1. So in that I will also show you the final matrix. Okay, but just here just know that this is how you're going to get the resulting frequency after 5 transformations. Okay, so here now initially your A is like this now, so A is converting to BC. Okay, so you are going to get this. Okay, so next time your B is converting to C and D. Okay, so you have to update this all this matrix. Okay, we are going to write the code, okay, for this. So here first you see here one thing, we are here talking about this power. Okay, exponentiation, right? So this is one base and we are taking the exponentiation. Okay, so how we are going to do that in case of matrix. Okay, so let's understand this first before jumping to this particular example number 1. Okay, so here this is one code. Okay, so here we are going to pass one matrix and here I'm going to say exponent. Okay, so let's suppose if you have this matrix. Okay, let's say you have this matrix given to us 3 into 3 matrix. Okay, and here I want you to compute the square of this. Okay, mat square. So you are going to write it like this, mat into mat. Okay, mat into mat, right? So here what you need to do first, you have to create the identity matrix. Okay, so in identity matrix what happens, all the values like this 0 0. Okay, at 0 0, 1 comma 1, 2 comma 1 2, 3 comma 3. Okay, 4 comma 4, but our matrix is of size 3 3 into, so only these 3. Okay, so here see all values are set to 1 and all other are 0. Okay, so this is going to have a starting matrix for exponentiation. Okay, and what is the purpose of this identity matrix? So if you are going to multiply any matrix with this identity matrix, you are going to get the same matrix result only. Okay, so it will not create any impact. So that is why we are going to take the identity matrix as base. Okay, result. So if you multiply this matrix now, we will also discuss how we are going to get multiply two matrices. Okay, we will also discuss that. Okay, so first let's understand this. So let's say this is your example and I want you to calculate this. So you take this identity matrix. Okay, so now here this step is done. Okay, this step is done. Okay, 0 0 1 1 2 2 3 3 4 4. Okay, this is done. Now I want you to square. Okay, so here exponent power is 2. Okay, and this matrix square I want. All right, so here what you need to do, so you are going to apply this matrix power, and here matrix you are passing and you are passing the 2. Okay, so here exp value is 2. Okay, so in binary you are going to write it like this 1 0. Okay, so 1 2. Okay, binary form. So, right, so this result is your identity. Okay, so now iteration 1. So iteration 1 here, iteration 1. So exponent is greater than 0, right? It is 2. So here you are going to check if first if it is odd or not. Okay, so here exponent and 1 if you do, so exponent is 2 now, so 1 0, and with 1 you do. Okay, 0 1, so you are going to doing and now, so you are going to 0. Okay, so you are not going to get 1. Okay, so if you are going to get 1, that simply means that it is odd. Okay, so if it is not odd, so you are not going to update this result. Okay, so this result is going to remain as it is. Okay, so do nothing with the result, right? And here square we are doing. Okay, so mat square, so this into this. So how we are going to do this? Okay, so what we are doing now, 1 1 0 0 1 1 1 0 1, and we are multiplying this with 1 1 0. Okay, square, we are taking the square. Okay, so we will also discuss how we do the multiplication. Okay, so here first you have to pick this row. Okay, and pick this, and then you have to multiply this with this all these columns. Okay, so here see 1 into 1. Okay, so now see 1 into 1, 1 into 0, 1 into 0, then 0 into 1. Okay, so 0 into 1, this is done. Okay, this is done. Now after that you have to select this. Okay, this now. Okay, again 1 into 1. Okay, 1 into this one, and then 0 into this 0. Okay, done, this is done. And then again same, but now you are going to pick this. Okay, so 1 into 0, then here plus 1 into 1, then plus 0 into 1. Okay, so this is what you are going to get. So this is you are going to get the 1 to 1. Okay, 1 to 1 is going to be the result, first result row 0. Okay, row 0 for result after multiplication. Okay, for now if you want to calculate a row 2, then again you have to select this, then again start from here 1, then next his, next this. Okay, so this is the rule. Okay, how we calculate the multiplication of matrix. Okay, so we have already studied this in our 10th class, right? 10th 9th class, I think so, right? So again row 1, so you are going to pick 0 1 1. Okay, so here I'm writing 0 1 1 and then multiplying it with complete this. Okay, so here just go over these details. Okay, let me do one thing here, let me little bit zoom it. Okay, now it is visible, right? Okay, so here same way we have to calculate this. Okay, then after that next row we have to multiply this matrix. Okay, then this is going to the result of mat square. Okay, so for this multiplication also there is one code. So how we are going to do that code? So here let's understand that. Okay, this is for multiply. Okay, so multiply, so two matrices you are multiplying, so just get the size of one. Okay, a dot length, and then this is the matrix that we have to fill. Okay, result. So here you see uh this is your a. Okay, so two matrices you are passing a and b. Okay, so a and b, so right, so you are multiplying these two. Okay, so here first time you are multiplying this with this. Okay, so your I 0, this I 0 and J 0 is remaining fixed, only this k values are changing na, k 0 with this. Okay, this with this k 0, this k1 with this k1, this k2 with this k2. Okay, so here at this position how you are going to fill the values? So I 0 k 0. Okay, I 0 k 0 means this element into k 0 j 0. Okay, plus I 0 k1 plus k1 into j1. Okay, k1 plus j0. Okay, so j0 is fixed. Okay, so here see only k0 this is changing na, k1 k1 and k2 k2. Okay, so this columns are changing for this particular row, and for this particular column rows are changing. So that is why I'm taking here k0 only, k here k. Okay, so here I'm taking kk only, and here I'm taking I and j. Okay, so here this is how we have to run this loop. Okay, so I, and then k. Okay, k is going to the changing factor, right, every time. Then here inside this we are going to run j. Okay, so then we are updating result I0 because I0 is not changing. Okay, so here see I and j are not changing here. If for this na I0 j0 I'm filling, so see I0 j0 I0 j0 I0 j0 for this particular. Okay, only first I'm taking k0 here, then I'm taking k1 and k2. Okay, so simple multiplication. Okay, so this is the code for that multiplication part. Okay, so I loop, then k loop, then here if any value is 0 then we no need to multiply, so that is why I'm adding this right. Simply skip, and then j is equal to 0, j is less than size, j plus plus, then result of I am updating as a of ik into kj. Okay, bkj. Okay, so this a I0 k0 b k0 j0. Okay, so this is b, a into b. Okay, so I am taking more side by side and I am operating the result as well. Okay, result 0 0 first we have to operate now. So in result 0 0 we have to add this plus this and this. Okay, for this I0 j0. Okay, so this is the code for this. Okay, so just go over this. Okay, for your clear understanding, so just go over this code and see this diagram. Okay, copy this and just try to understand. Okay, so it's very easy, nothing complex. Okay, just need little bit practice. Okay, so this is for this multiplication part. Okay, multiplication part is done, and these two only things are the complex. Okay, so here see this is done. So here for odd, okay, if it is odd, so if it is not odd then we are directly doing this. Okay, so here we calculate this. Okay, mat square we calculate this, right. Here we calculate this mat square. All right, so now here after that, here I have added anything? No, here I haven't added. Okay, so now once this is done once this is done, okay, so you are going to get some value here. So you are going to get this. Okay, mat square. Okay, so mat square you get, right. So now next time here you are shifting this exponent by you are doing left shift. Okay, so exponent is 2 1 0, so 1 0, so if you left shift 1, so here this is going to cancel. Okay, so 1 is going to remain there, right. So now here it is 1 is greater than 0, so 1 and 1, so you are going to get 1 this time, odd. Okay, so result is nothing but multiply this result and this mat square. Okay, result is nothing but the identical this one and into matrix. Okay, so matrix is nothing but your here mat square only. Okay, mat is nothing but this mat square only, and mat square and result. Okay, result is nothing but what is your result? So result is we have to calculate it here. Okay, here. Okay, identical, so we are just going to multiply these two up. Okay, and then after that result, here you are going to update the result as mat square into result. Okay, so you are going to get mat square value only. Then here you are going to update mat as multiply of mat square into mat square, so you are going to have mat 4. Okay, and then your exponent is going to become 1, and then again you left shift, so it's going to become 0, so you are not going to exit, but you are returning result now. So this is what you have to result you have to return. Okay, only result. So that's what. Okay, so this is the result of mat square, right. That's it. Now see this big example. Okay, so you are clear with the multiplication, right, and this code. So now see this. Okay, so let's suppose your exp is equal to 5. Now I'm not going to do this in detail. Okay, this multiplication, but you will get many here many dots will be created here. Okay, so binary is 101 of this 5. Okay, so now mat is your transformation matrix, so let's say size is 26 26. Okay, so initialize the result by as identity matrix, then you have to begin the loop. Okay, let me decrement the size a little bit. Okay, then the iteration 1. Okay, so iteration 1 exp is equal to 5 and binary is this. Okay, so exp and 1 you do, so you get 1. Okay, so result is equal to, now you have to calculate this. Okay, result was identity, so now result is going to become matrix. Okay, there will be no impact on, but now result is updated to matrix. Okay, right, result was identity, so identity into matrix if you do, so you get matrix only. Okay, but now it is updated to matrix. Okay, new is a matrix. Okay, then you have to do mat square, so here you get the value mat square. Now right shift, so right shift 101 101, so right shift if you do, so you are going to get only 10, that is nothing but 2. Okay, 2, right, and then iteration 2, so exp2 you are going to write it like this. Now here you are not going to get this value, then you have to skip this. Okay, then matrix is equal to mat into mat. Okay, so mat last time was mat square, so this is nothing but mat into mat is nothing but mat 4, right, because mat is equal to mat square from what before. Okay, so now again you have to do right shift So now you are going to get exp1. Okay, so exp1, so binary 1, so this is you are going to get over. Okay, so result is to result into matrix. Okay, so you know that from last time this was mat, and this mat was nothing but mat square, mat 4. Okay, so see this was mat 4, and here result was mat. Okay, this result, right? So here you are going to get mat 5. Okay, so square the matrix, after that it is going to become mat this is nothing but square the matrix. After that we are doing now, so mat 5 into mat 5. Okay, but was mat last value, mat last value is mat 4. Okay, so that is why 4 into 4 8. Okay, this is 8, mat 8. But now our this becomes 0 now, so we have to just return this part only. Okay, so in this part we are getting mat 5 now. Okay, so this is done. All right, so that's it. Okay, so clear. Now see this last example. Okay, a b c y y y. Okay, so here you are clear, right? This exponent code is important, right? So I have shown you the execution of this code and the multiplication code. Okay, so now after that, see this example, a b c y y and t is equal to 2. Okay, and this is a. If a is there, then only next one character, b is next one character only, c next one character, y next one character only. So here my a is going to become b, b is going to become c is going to become d, y is going to become z, and y is going to become z. Okay, now next time this b is going to become C, this C is going to become D, this D is going to become E, Z is going to become AB, because here next two we have to modify, and this is also going to become AB. So 1, 2, 3, 4, 5, 6, 7. 7 is the output for this. Alright. So here again you have to initialize the frequencies, right? So here A1, B1, C1 and Y2. Okay, so these are the frequencies. Initialize the frequencies. Done. Okay, now base matrix. So A is just converting to B, and B is converting to just C is converting to just D. Okay, only one now. But this Z is Y is converting to Z, and Z is converting to A and B. Okay, so here see Y, this is Y and this is Z. So Y is converting to only Z, but this Z is converted to both A and B. Okay, so here this is 1 1, right? So this is base matrix you have to create, and then you are going to get the final matrix, something like that. Okay, something like that, right? So now here how you're going to get, okay, so you are going to get the final matrix something like this. Okay, the exponential matrix, okay, max t that you are going to create. Okay, this exponential matrix, you already see the code for this. Okay, exponential matrix, right? And why we need, you already know that. Okay, we have shown you with the first example when a is there only, and we have asked to do 5 transformations, so we get 2 into 2 power 5 now, so frequency into 2 power 5. Okay, so that is what I'm going to do here. So resulting frequency after 2 transformations. So here first check this, check this, check this. Okay, so here this is for reaching a, so reaching a from a, reaching b to a, reaching c to a, d to a, e to a. Okay, same way reaching y to a and z to a. Okay, so here tell me, you can reach to a from a, from a you are reaching to a? No. From b and c you are reaching to a? No. From only y you are reaching to a, from only y you are reaching to a, right? So here from only y you are reaching to a, so y frequency is 2, right? Y frequency is 2 and you are reaching to a. Okay, so a is here, see, for a value is 1 and transformations is 2 into 1 per square. Okay, 2 transformation, huh? So you are going to get 2 only, right? Okay, so that is why this is 2. Okay, now same way next, this is for b. Okay, this second one is for b. Okay, so reaching a to b, b to b, c to b. Okay, so you are reaching to b here and here, so y to b and z to b. Okay, so z to b we can't reach now, because z itself is not there. From y we can reach to b. Okay, so we don't need to consider this one also. Okay, because z is not there now, so from y I can reach to b. Okay, so y, so y frequency is 2, b, okay, b is 1, and here 2 transformations. Okay, so 2, so that is why 2. Okay, so this is how you have to fill, and in the end just do the summation of all these values in this resulting frequency, and total length you are going to get as 7. That's it, very simple, right? Nothing complex, right? So now let's write the same code whatever I have explained. Okay, let's move to the coding part. So now I am going to write whatever I have explained. Okay, so nothing new, right? So here first just create one mode. All right, so since values can be very large, so we have to take a mode, right? So here you can write static final int mode is equal to 10 to the power 9 plus 7, right? So this is done. After that, you have to just calculate the frequencies, right? Frequencies of all the characters in your string. Okay, so here you have to write long frequency is equal to new long and size 26. All right, and then just iterate, use for each loop. Okay, so character ch in your string to carry, just change it to carry. And here after that, once this is done, so here you can write a frequency, take that particular character, and if you subtract a from that, so you are going to get that particular index, right? 0 if character is a. Okay, so just update that. All right, so we have calculated the frequencies. Now we have to build the transformation matrix. So here long, okay, and here matrix new long 26. Okay, so we have to check all the possibilities from a to a, from b to a, from c to a, same way from b to b. Okay, all that stuff we have to check. Okay, so this matrix we have to create. Now what base matrix we have to create first, right? So int I is equal to 0, I is less than here 26, and here I plus plus, and here inside this just calculate the length. Okay, so length is equal to nums dot get I. Okay, so like if nums is equal to 2 for a, so like we have to update just b and c now. So that place only we have to write 1 1, right? So what I'm going to do here next, that many characters we have to transform now. So here this is base case. Okay, first, so for int, so this is the case, right? A, so from a we can form bc now. Here it's 2, so from b to value is 2, so we can form cd. Okay, so base case. So here j you can write j is equal to start from 1, right? And here j is less than equal to this length, right? And here then after that j plus plus. Okay, so here you have to update like int uh, 2 is equal to here how you're going to get I value plus j. Okay, and here just take the mode. Okay, because after z we have to use a now again. So here mode with 26, and here mat I. Okay, from this I to 2, so we have to write it here like this, mat I, and here 2. Okay, 2, and then after that here plus 1. Okay, only 1 we have to add now. So here after that here just take the mode. Okay, maybe values can be very large, so just take the mode. So this is base matrix that you have to create. Okay, so this step is done, base matrix. Okay, then after that, once this is done, so now we have to create the matrix exponentiation, right? So we need a matrix and we need the power, right? All that stuff. So for that just create a new 2D matrix. Okay, and let's name it as mat t. Okay, and here I'm just going to call one method matrix power. Okay, and in matrix power what I'm passing the matrix and t. Okay, so this is what we need to pass, right? Matrix and the transforming. Okay, how many times we are transforming that, right? So here you already know the code for this, right? Matrix power. So I've explained the code here, so we are going to use this same code. Okay, so here you can do one thing. Let's write the code for this later on. Okay, we just paste this same code. Okay, so now after this, once we get this matrix, okay, so after that you have to multiply this mat t with the frequency vector. Okay, long, here let's say result frequency. Okay, and here new long, and here you have to write 26. Okay, this is done, and then just run. Okay, for int I is equal to 0, I is less than 26, and here I plus plus, and same here for int z is equal to 0, z is less than 26, z plus plus. Okay, then here you have to operate the result frequency of j. Okay, result frequency of j. All right, so how you're going to update this result frequency of j is nothing but result frequency of j plus. Okay, so here you can write it like this. Okay, here inside this just paste this. Okay, again and again we have to update this now. Result frequency of j is nothing but result frequency of j plus how you are going to write this mat t. Okay, whatever the value in mat t, so from I. Okay, from I letter to j letter. Okay, and what is the frequency? Okay, so here in mat t we have already calculated the power. Now we have to just multiply with this frequency now. Okay, so frequency of I, right? So here this is done, and here just do the mode. Okay, mode, right? So here what I'm doing, so see here this last step I have explained now, this, right? So here this is nothing but the frequency. Okay, and this value, right? So we have already stored, right? We have already got this value 1 square, that is nothing but this one. Okay, the value that is here, right? So this is very simple, right? Mat t I to j from letter I. So we have only in this first example we have only just A. So from A only we are getting this string na, B, C, then C, D, D, E, then D, E, E, F, E, F, F, G, then E, F, F, G, F, G, G, H, F, G, G, H, G, H, H, I. Okay, then again we get one more, right? So from A only we are reaching to all these characters, right? Starting from A, okay, A, B, C, D, E, F. Only we are going to get only one F. We are going to get 5 Gs starting from A. Starting from A, we are going to get 10 H's. Okay, so all this we have written here. Okay, so that's what I'm doing here. Result frequency. This is how I'm calculating the result frequency, right? So mat Dij. Okay, from the matrix I have to take that into frequency of I, and then just update this. Okay, so this is done. Once this is done, then after that you have to just then it's very simple now. So once you calculate all this, then you have to just update the total length. Okay, so that's very simple. Just create one variable long, and here total, and set it to 0, and then here just iterate over all the values one by one. So here long var is equal to result frequency, all right, and here total is equal to total plus val, right, and here mode, all right. So this is done, and then here you have to just return the result. Okay, return, and here int, and here you have to write just total. Okay, return type is int now, so that's why I'm changing it to int. Okay, so this is done. Now here after this you have to just paste this code. Okay, you have to write this code, and in this we are using multiply, so for multiply also we have to use this code. Okay, that's it. Only these two codes are pending, that's it. Okay, so let's write these two codes first. Okay, so very simple, right? So here private long, and here matrix power, right, and here you have to pass a matrix mat, and here after that exponent you have to pass. Okay, right, now here just calculate the size. Int size is equal to mat dot length, and then after that you have to get the new result now. So result is equal to new long, and here you can pass the size, and here size. Okay, and then after that you have to initialize as identity matrix. So for that you have to just run one loop for int I is equal to 0, I is less than size, and here I plus plus, and then after that here result, and here you have to just write I only. Okay, and you have to just update it with 1. All right, and then after that you have to just run one single while loop while this exponent power it is greater than 0. Okay, exp small exp is greater than 0, then in that case just you have to check if exp and 1. Okay, if it is equal to 1, all right, and then after that here just update result as multiply. Okay, and here result, and here mat. Okay, this r cap should be small, right? This result and mat. Okay, and then after that you have to just update mat is equal to here multiply, and here you have to just pass mat into mat. Okay, done, and then you have to just do the left shift of this by 1. Okay, so this is done, and from here you have to just return result. Okay, so this is the code for matrix power, and now once this is done, then that's it. Now here just write the code for multiply. Okay, that's it then, right? So here again private long multiply, and here long a, and here long b. Okay, and now inside this take size. Int size is equal to a dot length, and then take result is equal to new long size. So here let me just copy this now. Okay, let's save some time. Okay, this is done. Then after that you have to run the loops. Okay, 3 loops we have to run. Okay, int I is equal to 0, I is less than 20 size, and here I plus plus, and now your I and j is going to fix, only k is moving, right? So here what you need to do here, just run one more loop. Okay, for int k is equal to 0, k is less than size, and k plus plus. Okay, inside this if a I and k value, okay, if I k, okay, from first matrix only, if this value is equal to 0, then you have to just simply skip now. You don't need to multiply it with 0, anything with 0 only going to give 0 only, right? So here for next, okay, from next you have just select the columns. Okay, so j is equal to 0, j is less than size, and j plus plus. Okay, now your I and j is going to remain fixed now. So here I'm just going to write result of I and here j inside this, right? And here I'm just going to update it as result at this I and j. Okay, I'm just going to plus this with a of from a matrix, a of ik, Okay, and from next k into j. Okay, so b of and here k and here into j. That's it. Okay, and here once this is done, here just do the mod. Okay, that's it. All right, and here after that, just from here just return result. All right. Okay, so now let's run it and see if there are any code issues. We'll try to fix that. So yes, there are some issues, so let's see. So here what we are doing, so here we are passing matrix power, and here mat and t I'm writing capital. Why? What's the reason? It should be small now, right? Now let's run it again and see if there are any other code issues. We'll try to fix that as well. Oh, wonderful. Okay, now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in the comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.